Look around you. Technology is everywhere. Technology. 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 Technology? Or magic? Technology. Technology. One item that represents modern technology quite well is the compact disc. The compact disc has been around for about 28 years and was originally intended to be used solely for music. However, today you can find this little guy everywhere, being used in many different places for many different things. The compact disc is clearly an important part of modern life. But how does it work? How does this shiny piece of plastic contain your favorite music, or your favorite video game, or your favorite music? Let's ask someone who knows. Dr. Wylie Kulla is the Professor of Analog to Digital Conversion at the University of Technology. He has done extensive research in the area of technology, specifically in topics pertaining to analog to digital conversion. So here we are with Dr. Kulla of the University of Technology. First off, Dr. Kulla, what exactly is a compact disc?
Well, it's not terribly complex here. As you can see, I have this little drawing up here, and it tells the 4 layers of a compact disc. And the compact disc is 1.2 millimeters thick, and most of it's made up of this layer here, the polycarbonate plastic. And this here is a smooth layer here. But up in here, we have microscopic little pits in here, and that's where the data is actually going to be stored, is in these microscopic pits. And on top of that, we have our aluminum, and the aluminum fills in these pits and makes what appears to be bumps in there. And also, if you have a laser, then the light shines up and reflects off of the shiny aluminum surface and back down. And then the third layer of the laser then is the acrylic layer, and this protects the aluminum. And then on top of that, we have the label here. The label also has protection and provides that wonderful advertising of our Western culture that makes you want to buy it. But we won't go too far into that because it's that type of explanation. It's just how a CD works. So those are the 4 layers of a CD. And now over here, a CD has one continuous track, and this is made up of the bumps that are in the polycarbonate layer. And this track just goes around and around, one continuous track, all the way out to the edge. And this track is very, very thin. It's 0.5 microns. Very small, and that's about 200 times thinner than a human hair, so it's very, 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 very small. It's not big at all. And then it's 3.5 miles long, so just really long and really thin. Alright, so we have this track, and it's made up of all these little bumps, as we were saying. And these bumps, their dimensions on them are very, very small. So we have 0.125 microns high and 0.83 microns long. And as we said, the track width is 0.5 microns. So they're just, the laser follows these bumps around. The track's made up of the bumps, so the laser just sees these bumps and it uses that to follow around the track as it gets out.
So microscopic bumps actually hold the sound on the compact disc. How is that possible?
Well, if we look at, Jonah, if we look at a sound wave, it's an analog signal. So over time it varies as we change our pitch and frequency. And then what we have to do in order to put on a CD in the pits, in the bumps, we have to put it through an A to D converter, analog to digital, and change it into ones and zeros up the other side. So here we have our ones and zeros coming out the other side. So the first thing that has to be done is running this wave through our analog to digital converter, and then we get out the binary data that we can store on a computer and put onto a CD. And in doing that, what we're doing is we're taking a sample every so many seconds over parts of a second, and we're seeing what the voltage is, and then outputting that as data, as ones and zeros, at that rate. And also with that we have, that's called the sampling rate, but we also have something called resolution. And our resolution is 2 to the n, where n is the size of your word, or your binary word. So you have so many divisions this way. And say you have n equals 4. So you have a binary word size of, say, 4 here, like this, 1001. That would give you a word size of 4, and 2 to the 4 would be equal to 16. So you'd have 16 different levels of resolution. And so that's, as you increase your resolution and your sampling size, you get a higher resolution. And then, so we finally get all this data out, and we put it on the CD. And on a CD, then, as we transition from a high bump to a flat to a bump, then this transition here is going to be the 1. But if we're on a flat, that will be a 0. And then if we're, so anytime we're on a flat, we have a 0, and any transition is a 1.
That doesn't sound too complicated. So the audio is basically stored in ones and zeros?
Well, basically, but it's a bit more complicated than that. In order to keep the data from being corrupted, there's a lot of formatting that's done to a CD. The first thing to do is called EFM. This stands for 8 to 14 modulation. Really small. And that basically says that we have a data bit coming out of raw data from our analog to digital converter that has 8 spots. So maybe this here. And say so we have an 8-bit word size. And if we had one that came out as 1 0 0 0 0 0 0 1, well, this would mean then that we had some change and then a flat for a long time. Well, our laser follows the changes. That's what it's following around. So if we have a long flat, then the laser is going to get lost and not going to be able to read the data correctly. So in order to ensure that doesn't happen, they put it up to 14 bits and insert just ones in there, some changes in there, so that the laser won't get lost as it goes around. So they basically effectively just extend it, put more data into it to make sure the laser can follow it. And then another thing is just parity bits, which checks for errors. And so the parity bits are added in, and they use them to figure out whether there's a scratch that's caused some bits to be missing or not, and to fix it.